Hello, this is Professor Eckhouse, and I'm going to talk today about section 2.5, which is prime factors and least common multiple. That's what LCM stands for. So I am this portion in green here under the prime factorization of a number. There's two different methods, factor tree method and ladder method. I will not talk about ladder method in class, but I am going to do it here for those who are interested. And you can also look at the book. All right, so I'm going to look at finding listing multiples as well as finding prime factors. All right, so prime factor using a factor tree, you can look at this list of how to do it, but I'm just going to show you instead of reading through it for you. All right, know the first 5 or 6 primes. That will really help. So the first 5 or 6 is just important to know. The first prime is 2, then 3, 4 is not prime because it's divisible by 2, and then 5, 7, 8 is not because it's even, 9 is divisible by 3, 10 is divisible by 2 and 5, so the next one is 11. So, and the next one after that is 13. So those are good ones to know, and I believe the next one is 17. So, all right, so those are the first primes you need to know. Just have that written down somewhere. Just start trying to remember that those are the first primes. That will help you to do these methods that I'm going to show you. So I'm going to show you how to use a factor tree to find the prime factors of 36 and write in factored form. So you might want to pause this, go look at the instructions, see if you can figure it out and try to do it. Otherwise, I'm going to show you. All right, so the thing about this is there's always multiple ways to do it. And the bigger the number, the more ways there are to do it. So the way I'm going to show you is not the only way. I could show you 2 or 3 ways and you could still do it differently from me. So what you want to do first is write down the number, and then we're going to make a tree. So we're going to go like this, and we're going to say what 2 things multiplies to make 36. Well, there's lots of things. There's 2 and 18, there's 6 and 6, there's 4 and 9. It doesn't really matter because in the end we're going to get the same answer. So I'm going to do 6 and 6 because that's the first one that popped into my head. Okay, I'll show you 2 different ways here. 6 factors down, I think, does 2, always start with 2 and 3 and 5 and see if those numbers go in. So does 2 go into 6? Yes, it does. It's 2 times 3. Okay, so now 2 is prime. I'm going to put a circle around it. So is 3. 6, this other 6 does the same thing, 2 and 3. All right, so now we're done. Those are primes. You can't factor those anymore, so we are done. All right, so you're going to be asked to write it in factored form and then in exponential form. Okay, so factored form is just going to be in order 2 times 2. So you've got to go look for all the 2's, 2 times 2, and then the next number is 3, and there's 2 of them, times 3 times 3. Now, are you right? Go put it in your calculator. 2 times 2 times 3 times 3. Do you get 36? That's how you check. Okay, so use your calculator. So that is the factored form, and then the exponential form is 2 squared times 3 squared. Okay, so that is the exponential form. Okay, so I'm going to show you a different way and just show you that we get the same answer. So 36, let's just say that you chose 4 and 9. Okay, so the 4 is going to factor to become 2 and 2. Now those are both prime, 2 times 2. And then 9 is going to factor to become 3 times 3. So 2 times 2 times 3 times 3. Again, it is exactly the same as that. Again, you would write it in exponential form like that. Okay, exactly the same as that. Same. Right? So, and there's another way, 2 times 18. I think that's it. All right, so why don't you try to do 48, pause the video, and see what you can do with it. All right, so I'm going to do 48. The first thing that jumps to mind is 4 times 12. You might have thought of something else, but that's what I thought of. So the 4 factors to 2 times 2. Those are prime, so I'm going to stop there with the 2 times 2. 12, you can say 3 times 4 or 2 times 6. It doesn't really matter. I'm going to say 3 times 4. All right, the 3 is prime, the 4 is not. I'm going to keep going until I get all primes. Okay, so now I'm going to find all my 2's, and I'm going to say 2 times 2 times 2 times 2. That is factored form. And then, oh, I'm not done yet, times 3. Factored form, sorry. All right, 2 times 2 times 2 times 2 times 3. There's 4 2's. So I like it better like this. 2 to the 4th times 3. It's less writing, and it's also a little more clear. You don't have to count. So 2 to the 4 times 3. Now check on your calculator. Take 2 times 2 times 2 times 2, or use the to the 4 button, the caret. So you would say you would say 2 and then use the caret, or there's also like an X to the N key on some calculators. And then, all right, then you would do to the 4 and then say times. Now you're going to have to use the right arrow to get out of the exponent, right? So then say times 3 and enter. And that should give you 48. And again, if you do it a different way, you should get the same answer. So you might have said 2 times 24, and that's fine. All right, use a factor tree to find the prime factors of 84. Again, pause it and see what you can do with this. All right, so 84. I see 4 times 21. That's one way to do it. So we would have 4 makes 2 times 2. 2s are prime. 21 is 3 times 7, and both of those are prime as well. Again, knowing your primes is really going to help because you'll know when to stop. So factored form, 2 times 2 times 3 times 7. Exponential form, 2 squared times 3 times 7. Again, check. See if you get 84. These are the easiest things to check on your calculator, so why would you not check? All right. So there's another method. I'm not going to talk about this in class. This is using the ladder method. And here's the steps. You can come back and look at this later, but I am going to show you, starting with the same number that we had before. All right, this time we're going to start down low. Okay, we're going to start right down here, and we're going to write 36 with a division sign. Okay, and I'm going to start with the smallest prime I can think of, 2. So does 2 go into 36? Yes, it does. 2 times 18. Okay, so I'm going to go back to black. Try to keep this really clear. 2 times 18. All right, now, does 2 go into 18? Yes, it does. And 2 times 9 is 18. If you are not really good with long division, this might not feel very good to you, so that's why I like the other way. All right, does 2 go into 9? No, it does not. Does 3 go into 9? Yes, it does. So 3. 3 times what is 9? That's 3. All right, so what we're left with in purple there it is also in order. So that's why some people like this, I think, because it's in order. So we get 2 times 2 times 3 times 3. So you start with the smallest prime. If it's not divisible by that anymore, you go to the next one, the next one, the next one. Okay, so they end up being in order. So 2 squared times 3 squared. So check that and see if you get 36. All right, so, and these, there's only one way. There's really only one way because you start with the smallest number you can think of and you just go from there. So I'm going to show you another one. So we've got, again, start down low. So you've got 120 and I'm going to start with 2. Okay, so I put 2 in and I get 60. Okay, so divide by 2 and I get 60. Does 2 go in again? Yes, it does. And what do I get? I get 30. So 60 divided by 2 is 30. Right, let's do it again. Does 2 go into 30? Yes, it does. How many times? 15. I want to make that black. All right, how many times? 15. All right, does 2 go into 15? No. Does 3 go into 15? Yes, 3 goes in. How many times? 5 times. Okay, so 5 times. All right, 5 is prime. Oops, so I'm going to actually go back to purple because it is prime, and so it's our last number. So we have 2 times 2 times 2 times 3 times 5. Okay, so 2 times 2 times 2 times 3 times 5 is written like that in factored form. Exponential form is 2 cubed times 3 times 5. Now, we don't generally put the 1. It is a 1, but we don't usually put it. Okay, so those are the 2 versions of your answer. All right, so again, this is called stacked division. Okay, the other questions, I'll zoom back up here for just a second. This was the factor tree method. This is called stacked division. All right, so use stacked division to find the prime factors of 198. So again, starting down low, 198. Is it divisible by 2? Yes, it's even. So how many times does it go in? Boy, I didn't do this one ahead of time. It would be 99. 99 times? I think. Is that right? Guess so. Okay, so I have a different answer in my key, so I think I was doing a different problem. So 99 times 2, I'm just double checking, is going to be 198. Okay, sorry, I'm doubting myself here because I don't have the key right. So does 2 go into 99? No, it does not. But does 3? Yes, it does. And 3 is going to go in 33 times. 33 times. All right, so does 3 go into 33? Yes, it does. So we're going to say 3. How many times does it go in? It goes in 11 times. 11 is prime, so I'm going to write it in purple. So I get 2 times 3 times 3 times 11. And I'm actually going to stop and check on my calculator. So I'm going to put in 2 times 3 times 3 times 11. I can't go back and fix these videos, so I want to make sure I've got it right. 2 times 3 squared times 11. Great. Okay. So that's how you do that one. And I'm going to actually take this right here and I'm going to move it up. There we go. All right, so finding the least common multiple with the listing multiples method. All right, so this is one method. It doesn't work very well when you have two numbers that are very different from each other and you end up having to list like 20 multiples. It is a drag. So this is one way of doing it. So let's try it. So we've got 10 and we've got 25. So sometimes you don't have to list very many. So we'll see 10, the multiples of 10. So this is called finding the least common multiple. So think about what that means. So we're finding a common multiple, the smallest one. There's going to be an infinite number of common multiples, but we're trying to find the smallest one. Okay, so the first multiple of 10 is 10 times 1, then 10 times 2, 10 times 3, 10 times 4, 10 times 5, 10 times 6, and it can go on. And I'll write more if I need to, but I'm going to stop there. Okay, 25 times 1, 25 times 2, 25 times, oh, wait, I see it. Yeah, so you got to pay attention. So 50 is the least common multiple. If I kept going, I would find another one. There will be more, lots more, but you want the least common. Okay, so we're just going to stop. So the least common multiple, the way you would answer this, is the least common multiple of 10 and 25 is 50. All right, so let's do that again for number 8, example 8. So why don't you pause the video, I'll leave that there so you can see it, and try this one. All right, so we've got 8 and 14. So I'm going to do this with the listing method one more time. So 8, 16, 24. So times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, and times 9. Okay, so 14 is going to be, let's change colors here. 14 is going to be 14 times 1, 14 times 2, 14 times 3, 14 times 4, 14 times 5, I think is 70, but I'm going to stop because I see 56 here. And again, I could keep going. There will be another one and another one and another one, but I want the smallest, the least. Remember that least means smallest. Okay, so that is one method. Now there's another method, and here's the steps. I'm not going to read them to you. You can pause and read them if you'd like, but I'm going to show you. All right, so the book does it like the way on the left. You can also do it the way on the right. It's a little bit of a shortcut, so you don't have to write quite so much, and sometimes it makes a little more sense to people. Either way is fine with me. It doesn't matter, and I'm going to show you this. So what they've done here is they have taken 12 and they've listed all of the prime factors. So you've got to list the primes. And then for 18, they have also listed the primes, but they have lined them up so that the numbers are underneath. And what you want to do is find the least common multiple by saying, all right, well, I need to take one from each. Okay, even if there's nothing matching up with it. So that will give us magically the least common multiple. It's not really magic. If you used a Venn diagram to do this, you would see it. All right, but another way to do it is to list them with the exponents. I'm going over here to our other method. So list them with the exponents and choose the ones with the highest exponent. So going over here, the 12 could be written as 2 squared times 3 to the 1, right? And 18 could be 2 to the 1 times 3 to the 2. And what you do is you go and you say, all right, I'm going to look at the 2's. Which one has the highest exponent? 2 to the 2. So that's the one I'm going to pick. So pick the one with the highest exponent. All right, so LCM is going to be 2 to the 2. Now let's look at this one. Which one has the highest exponent? and that is 3 to the 2. Okay, so times 3 to the 2. So 2 to the 2 times 3 to the 2 is 36, and that's the least common multiple. So either way you want to do it, lining them up and drawing arrows down, I prefer the exponent method. It's just, I don't know, a little tidier, but whichever one you prefer. I'm going to show both. All right, so we've got 15 and 18. I'm going to do 18 first because it's got more stuff going on, so I can line things up. 2 times 3 times 3. All right, and if you want to, you can use a factor tree, right? So I could say 18 is 2 times 9, and 9 is 3 times 3. So 2 times 3 times 3. Okay, so that's how I get this up here. All right, so 15 is 3 times 5. So 3 times 5. All right, so now we're going to line these up and say every single time I have a line of stuff, I'm going to bring it down. So, oops, those two don't line up. What did I do wrong? The 5 and the 3 don't line up, so I need to put the 5 over here by itself. All right, so I get the 3's like this and a 5 by itself. See, this is where I find it just a little bit confusing because you have to line it up really well. So I get a 2 times a 3 times a 3 times a 5. All right, so if I put that in my calculator, I get 90. So the least common multiple of 15 and 18 is 90. If you want to use a listing method to double check and make sure you're doing this right the first few times, I would. But the other way is to think, all right, 15 is going to be 3 to the 1 times 5 to the 1. And I'm going to leave a blank for the 2. Okay, so 18 is 2 to the 1 times 3 to the 2, and then no 5. So there's a blank there. Okay, so now I go through and I choose the one with the highest. So out of the 2's, which one has the highest? Well, hopefully it's obvious that it's the 2 to the 1, right? Just 2 to the 1, and you don't have to write the 1. All right, the next one you're going to look at is the 3's. So which one is the highest? That is the 3 to the 2. 3 to the 2. And then you're going to look at the 5's. Well, there is no 5 down below, so the highest there is 5 to the 1. All right, so put that in your calculator again, you get 90. Okay. All right, so let's try this again. Using the prime factor method, not the listing method. Let's do 27 and 15. So why don't you pause the video and give this a try. All right, so 27 and 15. 27 is 3 times 3 times 3. 15 is 3 times 5. So I'm going to go 3 times 3 times 3. I don't have to worry about the 2's. And 15 is 3 times, well, I don't have another 3, so I'm going to bring it over here and make it a 5. So I'm going to do the arrow method here. So bring those down, bring that one down, bring that one down, and bring the 5's down. And I get 3 times 3 times 3 times 5, or 3 cubed times 5, which is 135. All right, the other method, the one I use with exponents that I prefer, is it's 3 cubed, that's 27. And if you use a factor tree, you'll see it's 3 cubed. And 15 is 3 to the 1 times 5 to the 1. Well, I don't have a 5 here, so let's choose the highest for the 3's and the highest for the 5's. Okay, so the highest for the 3's is going to be 3 cubed, and I'm talking about the highest degree, the highest exponent. And the highest for the 5's, well, there isn't one for 27, so it's 5 to the 1. So again, we get 135. All right, one more. Why don't you try this one? Okay, so pause the video if you haven't and give it a try. All right, I'm going to do 60 first because I know there's some 2's in it. So if you go use a factor tree, right, you would use a factor tree and you would get, let's see, maybe 2 times 30, there's my prime. 2 times 15, there's another prime. And then I get 3 times 5. Those are my primes, all primes. Okay, so I get 2 times 2 times 3 times 5. All right, so 2 times 2 times 3 times 5. And 55 I know is 5 times 11. So 55 is just 5 times 11. Those are both prime. So, all right, so I get, I'm going to start way over here, 5 times 11. Give myself a little more space so I can write my arrows. and I get the arrows coming down here, 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 the 5s, and the 11. So I get 2 times 2 times 3 times 5 times 11. And when you put that in your calculator, you should get 660. That would take a long time to write all those out, but you can do that in the list method if you really want to. But I would like to see you trying this. All right, I'm going to do this with the exponent method. So 55 is just 5 to the 1 times 11 to the 1. 60 is 2 to the 2 times 3 to the 1 times 5 to the 1 times 11 to the 1. So for the 2's, what's my highest exponent? Well, that's that one, 2 to the 2. For the 3's, it's that one because it's the only one. For the 5's, what's the highest? Well, they're both 5 to the 1. And for 11, 60, I screwed up. Yeah, no 11. There's no 11 there. All right, so the 11's, the highest is in the 55, and that's going to be 11 to the 1. So you don't have to put the to the 1's again. So you get 2 squared times 3 times 5 times 11. And again, you get 660. So these are the same method. It's just writing it down differently. One, I write it all out in factored form. The other way, I write it out in exponent form and just know I go with the highest exponent. All right, I think that is it. Thanks for watching.